Now there are many different devices for this, which allow you to detect the enemy at the right time and prevent unwanted guests. One of these devices is a radar, which records the approach of ships and aircraft. Of course, engineers strive to ensure that warships or aircraft are invisible to radars, but radar developers do not sit idly by. Today, we'll take a look at one of the radars that cannot be fooled by existing technologies. Moreover, this radar has no analogs in the world. We're talking about the Dawn 2N radar. Are you ready to be surprised? Let's go then. A giant structure resembling an unfinished pyramid of Cheops, which only very curious travelers in clear weather can see between Sofrino and Pushkino. This is the main character of our today's video. This is a unique, fully completed Dawn 2N radar station, which is often called the eighth wonder of the world by the military due to its appearance, technical characteristics, and incredible cost. The Dawn system near Moscow has managed to implement low features that make it so unique. First of all, this radar is multifunctional. Usually radars can detect a ballistic target, and this one, in addition to this, can also accompany anti-missiles and make long-range and short-range interceptions, while exchanging encrypted information. It has high noise immunity and can detect targets at an altitude of 40,000 kilometers. Also, Dawn 2N can track the target within 10 meters, and the warning time is only 9 minutes. Can you imagine? And if we add that the Dawn 2N was built back in the 90s, then these characteristics are generally pretty impressive. Its construction took more than 32,000 tons of metal, 50,000 tons of concrete, 20,000 kilometers of cable, and more than 100 kilometers of pipelines, with 10,000 cast iron valves to the pipelines, since a huge amount of water is required to cool the equipment. Crazy numbers, right? Dawn 2N is a giant concrete structure in the form of a truncated pyramid. Phased antenna arrays are located on each side of the Dawn 2N's radar. Each array contains 60,000 emitters that have been operating for more than 10 years, continuously scanning the space around Moscow at a distance of more than 3,500 kilometers. The phased antenna array is the real feature of the Dawn 2N. It's been in development for 25 years. The phased array forces the beam to rotate when the antenna is stationary, and in traditional radars, reflectors swing on turntables. The idea of a phased array itself is far from new. In order to swing the beam with a stationary antenna, you need to learn how to tilt the field front. In a traditional radar, the front is strictly perpendicular to the emitter, and in order to direct the beam, you need to rotate the antenna itself. If the antenna is divided into thousands of small emitters and taught to change the phase according to a given algorithm, though, then a plane wave can be launched in any direction. A phased array radar can generate multiple beams at the same time, so the Dawn 2N radar can simultaneously track 30 targets. With such impressive technical characteristics, the Dawn 2N performs several very important tasks. So, the Dawn 2N radar is included not only in the anti-missile defense system of Moscow, but also monitors outer space. It also closes holes in the early warning system and accompanies small high-speed targets, that is, warheads. In addition, Dawn 2N must reject false targets, bypass interference, and issue coordinates for attack. This is an extremely difficult task that only the most powerful supercomputer Elbrus can solve. This computer was designed specifically for this type of radar. To fulfill its tasks, the Dawn 2N radar is equipped with thousands of cabinets with electronic equipment in Elbrus, which occupies an entire floor. Dawn 2N does an excellent job of protecting airspace. Radar allows you to identify targets at distances of thousands of kilometers with optical accuracy. The general designer of Dawn claims that the radar can even see a tennis ball flying over Europe at a speed of several thousand kilometers per hour. Such loud statements confirm the results of the experiment that Dawn 2N successfully passed at the end of the 20th century. It was a kind of stress test in the framework of the Joint Anti-Missile Program of Russia and the United States called ODIRACS. So, from the American shuttle Discovery in space, metal target balls were thrown, and the most powerful radars in the world tried to detect them. 15-centimeter spheres were detected by everyone. Balls with a diameter of 10 centimeters were seen by only 3 radars, 2 Russian and American Kobra-Dane in Alaska. Finally, the shuttle threw out 2 5-centimeter balls. Only the Moscow region Dawn discovered and built the trajectories of miniature targets, having deservedly won this competition among radars. Despite such brilliant results, the power of Dawn still has its limits and its weaknesses. In Dawn 2N, this is the impossibility of coping with anti-missile defense, or abbreviated missile defense in case of a massive raid. Also, when launching ballistic missiles with many dummy objects, it'll be very difficult for Dawn to recognize where is the true and where is the false target. Knowing these imperfections of the Dawn 2N radar, engineers are constantly trying to modernize it. So back in 2019, the head of the Department of Combat Algorithms and Programs, Colonel Ildar Tagiev, told the media that at the moment the A-135 anti-missile defense system is undergoing a deep modernization, aimed at improving its characteristics and increasing its efficiency. Unfortunately, the details were not disclosed. The peculiarity of the current modernization is that the existing components of the system are gradually replaced by new ones without losing their performance. They're constantly trying to apply the latest innovations in the field of technology to Dawn. So at the beginning of this year, the processor was replaced in the main computer of the Elbrus radar system. This made it possible to increase the speed of Dawn calculations by 10,000 times. Its performance has increased to 100 billion operations per second, and power consumption has decreased 40 times. In addition, the replacement of the previous generation system based on the processor made it possible to reduce the size of the equipment, the number of blocks and cells, which had a positive effect on its reliability and its maintainability. As you can see, the engineers are closely watching their Pride, one of the key missile defense stations in Russia. They're gradually modernizing it, doing everything possible to close the weak points of Dawn. Unfortunately, most of these improvements are kept in strict confidence, and this is quite understandable, despite the fact that there's no analogs of such a radar in the modern world. We'll keep a close eye on news regarding Dawn and other Russian missile defense targets. Subscribe to our channel and you'll be the first to know about everything.